Complete and balance the redox equation. What is the coefficient of H2O? So we are given this equation in an acidic solution. First, we need to break down the equation to find out what is oxidized and what is reduced. In doing this, we find that MnO4 negative yields to Mn2 plus is what is reduced, and SO3 2 negative yielding to SO4 2 negative is what is oxidized in this problem. This is the first step and is crucial to solving these problems. Before we begin, we must make sure that each equation is completely balanced on both sides. This means that the number of atoms in total charge must also be balanced. We first began by balancing this equation. MnO4 negative yielding to Mn2 plus. We see that on this side we need oxygens. Therefore we need to add water. Since there are 4 oxygens on this side, there will be 4 oxygens here. So there will be 4 waters on this side. Now, once we add waters, we see that we need the hydronium ions. So we have 8 hydronium atoms, so we need to add them. So it would be MnO4 negative plus 8H plus yielding to Mn2 plus 4H2O. Now we have a balanced equation. Now we need to balance SO3 2 negative yielding to SO4 2 negative. So we look at the same thing. SO3 2 negative plus 1 water yielding to SO4 2 negative plus 2 H ions will balance the whole equation. So because we needed 1 oxygen here, we needed to add it, therefore we used the water. Now we need to balance charges. So SO3 2 negative plus H2O yielding to SO4 2 negative plus 2H plus 2 electrons. Now we have a total number of correct electrons, charges, and atoms on both sides. Now that we have balanced both half reactions, we put them together. However, the total number of electrons must equal on each side of both reactions. Everything must equal each other or it will not be balanced. So these are the 2 half reactions that we have. Due to the fact that our charges in this equation were not balanced, we need to balance them. So the left side of the equation has a charge of plus 7 and the right side has a charge of plus 2. That is evidently not equal. So we need to add 5 electrons in order for it to equal. So once we add that, we have MnO4 negative plus 8H plus 5 electrons yields to Mn2 plus 4H2O. Now we have we are comfortably balanced because we have both sides equal to each other. Now that we have got both half reactions completely balanced, we must multiply both equations by a number to get an equal number of electrons. Remember, everything has to equal. So if we balance this equation by multiplying by 2 and balance this equation by multiplying it by 5, we see that both sides now have 10 electrons because 5 times 2 is 10 and 2 times 5 is 10. So now we are completely equal. After doing this, we can finally write our completely final balanced equation. But before doing this, we need to cancel out likes. So we have H here and H here. So if we cancel out 16 and 10, that leaves us with 6 hydronium ions. We have 8 waters and 5 waters here. If we cancel them out, that leaves us with 3 waters. Our electrons completely cancel out. That was the whole point of getting them equal. So now our final balanced equation is 5 SO3 2 negative plus 2 MnO4 negative plus 6H plus yields to 5 SO4 2 negative plus 2 Mn2 plus 3H2O. If you notice, our coefficients match each other, not completely, but they are equal on both sides. Coefficients do not have to match as long as both sides are equal to one another. Therefore, we see that the coefficient of water is 3.